Hello, in this video, I will explain to you on how to solve this problem. For the following exercise, consider a right cone that is leaking water. The dimension of the conical tank are height of 16 feet and radius of 5 feet. Find the rate at which the surface area of the water change when the water is 10 feet high if the cone leaks water at a rate of 10 feet cube per minute. Okay, now let's see it here. We have the water leaking here from this hole here with the rate of 10 feet cube per minute. So we'll have dV dt here, and the rate is minus because the water is decreasing. So we'll have minus and then 10 feet cube per minute. Good. And then we need to find out the surface area of the water. Okay, we have to be very careful here because the surface area of the water is not the surface area of the cone, because here the water surface is this one, right? So this is the water surface. And this part here in the side of the cone is not the surface of the water, right? So in this case, the water surface form a circle and not a cone, right? And so we need to find out the rate of change of the surface area of the water. Okay, let's start with the relationship between R, H, and 5 and 16. We can use similar triangles because the water and the cone forming a similar triangle. Let's start from here. We can compare the base of the water here, which is R, divided by the base of the tank, which is 5. This is base divided by base. And now we have the height here. So I will have H and then divided by the height of the tank, which is 16. And I can isolate for H here. So we will have H is equal to 16 over 5 multiplied by R. Good. Now we need to find out the rate of the radius here with respect to time, because it will be helpful to find out the water surface area change. Okay, and we can start from the volume of the cone. Volume of the cone. And what is the volume of the cone? We know that P is equal to the base area. So we'll have 1/3 of the base area. And the base area is circle. A circle is pi r squared, the area of a circle. And then multiplied by the height. So I'll have height here. But then we can plug in the height, which is 16 over 5 multiplied by r. Okay, so we'll have P here is equal to 1/3 of pi multiplied by r squared and then multiplied by 16 over 5 multiplied by r. Then what is here? The P here, the volume is 16 over 15 multiplied by pi multiplied by r to the cube. Good. And then we need to differentiate this formula with respect to time. So rate of change of the volume. Of the volume. Okay, what is the rate of the change of the volume? It is dV dt, right? So we will have dV dt. dV dt here. And then what else that we can get? On the right hand side, we only have r here. So I will have dV dr. Then multiplied by dr dt. Good. And now let's use power rule to differentiate this. So I will have dv dt is equal to 16 over 15 multiplied by pi multiplied by 3 r squared, right? Because that is the differentiation of r to the third power with respect to r. And then multiplied by dr dt. Good. Now 3 and 15 will cancel out. So I will have 5 here. And so we will have dv dt that will equal to, I think we will have 16 pi over 5 and then multiplied by dr dt. And what I want is I want to isolate dr dt. Okay, let's clean this up first. Okay, now let's isolate for dr dt. So we have dr dt here is equal to, I think we will have 5 over 16 pi multiplied by dv dt. Okay, let's leave it as is here. Okay, we need to find out the rate of the surface area. So we have to find out the surface area of the circle of the water here. Remember that the surface area here is A is equal to pi r squared. So that is the area of a circle here, the surface of the water. And then we need to find out the change. So we have to find out dA dt here. And dA dt is equal to dA dr multiplied by dr dt. And we can calculate this part here using power rule of this function here. So we can have dA dt here, dA dt, and that will equal to 2 pi r. Okay, so I have 2 pi r multiplied by dr dt. Good. Now, what else that we can have? Dr dt here is this function here. So let's plug that in once again. So I will have dA dt here is equal to 2 pi r multiplied by 5 and then divided by 16 pi, then multiplied by dv dt. Okay, so we will have pi and pi here. And then 2 and 16 will cancel into 8. So here we will have dA dt. dA dt is equal to 5 over 8 and then multiplied by r multiplied by dv dt. But here we are given the height and not the radius. So we need to convert this r into radius. So we can just plug in this one here, right? So h is equal to 16 over 5r, or we can also use this as r is equal to 5 over 16h. Okay, now let's plug that in here, but I think it is full, so let's clean this up. So now we can plug in that r in, and that r is 5 over 16h. Okay, so we will have dA dt, and that will equal to 5 over 8, and then multiplied by, remember, what is it? 5 over 16h. 5 over 16h, then multiplied by dv dt. So we have it, dA dt here is equal to 25, and then 16 multiplied by 8 is 128, and then multiplied by h, and then multiplied by dv dt. Now what can we do? We plug in the numerical values. So plug in numerical values, which should be always your last step. So we will have dA dt here on the left hand side when the h is equal to 10 feet, right? So we'll have 25 divided by 128 multiplied by 10, and then multiplied by minus 10. And so we will have minus 2500 divided by 128. And the unit here is feet square per second. Or we can just plug in the numerical values into calculator. So we will have minus 2500 divided by 128. And that will equal to minus 19.53. Minus 19.53. And the unit here is feet square per second. Okay, hopefully I did not make any mistakes during my calculation. It is very long one, so let me know if I did. And thank you for watching. See you in the next video. Bye bye.